In the previous three videos, we've looked at creating a random hex colour string in exam reference language or OCR exam reference language or pseudocode. We then looked at how to different ways to get a random hex digits, and we converted that code to Python. And in the third video, we converted that code to Visual Basic. In this video, we're going to then do a simple conversion from the exam reference language or pseudocode to C#. And I suspect that not many schools are using C#. However, I have taught students using C#, and there are a number of little gotchas when we are converting this to C#, particularly when we think about the code and its similarity to the code that we just had working in Visual Basic. So all I've done again is copy and paste the pseudocode into this bare C# console application. As I did with the Visual Basic, I'm just going to take these and put them into here. And then what I'm going to do is that we will need to remove the word function, and because we're in a static void, or we're calling it from static void, then I'm going to have to go static, and this is going to return a string. So static string, and in this case we're going to use curly braces, and I'm going to copy this code here because we don't need the end function. So in a similar vein as to the video 3, we want to say string lookup, and we want to use that lowercase, and we mustn't forget our semicolon in C#. This is going to be an object or random object, so we're going to say random, and we're going to follow the same pattern. Object is equal to the new random, and in the same way, if I could type, is we also want to then say that our it's an integer, and we call that R&D, is equal to our random object dot next and 0 to 15. You'll notice how similar, if you've looked at video 3, this is to the Visual Basic code. And so in this particular case, our hex digit is again a string. Technically it's a character, but we're simply using a string of length 1, and we're now using lookup. And what is the issue here? Let's just first of all understand what's going on here. If we hover over this, cannot convert char to string, and that's the point that I was making, is that in reality this returns a character from that string, and so we have to do what's known as casting or conversion, and we can simply tell it to do a string. However, one of the more easier ways is just to use the toString, and that will cast it to a string, and then we're returning that hexadecimal digits. Now we're going to do here, and we're going to say static again. This is static, and it's going to return a string, and we want to use our open and closing curly braces. I'm going to put that into here and remove that. So again, this is a color string, it's a string, so we're using that. Now in C#, we certainly don't have a for loop in the same way. We can say for brackets int c is equal to 0, c is less than 6, so that will go 0, 1, 2, 3, 4 and 5, and then we want to increment C on each count, and then we can do these two things twice. We don't need that, and we're going to finish this up in a minute. So again, our digit is going to be a string, so we're going to declare that as a string, and then we simply are concatenating. We just need to remember our semicolon, and we need to remember our semicolon here. You'll notice that this is giving us a red squiggly line, and so this code is very similar. Again, this is a string, so we need to declare that to be a string, and just in exactly the same way as Visual Basic, we can write console.write line, and don't forget our semicolons. And so this code is very similar to the Visual Basic, except for the way that we do a for loop, and instead of saying dim digit as string, we simply use the data type. So hopefully that should work, given that the code is almost identical. So let's run this code now and see what we get. And there's a problem. For some reason in C#, it wants to just close the console app down. So all we can do here to prevent that from happening is just do console.readline, and that'll simply wait for us to press enter before it closes. So let's try that now. And this time you'll see that we get all the same number. If I run it again, that was all false. This time it's a different random number, but it's the same number for each of the 6 characters. And just to prove it, I'll do it one more time. And that's strange because we're using the exact same code in that we're generating a random object and using the next method on that. So what's the problem? Well, if you go to video 3, we talk about a seed, and a seed effectively determines the pseudo-random nature. So if I use a seed of 1, then every time I run this program, it might be 1, 3, 5, 7 as the random numbers, and if I then run it again, it will be 1, 3, 5, 7 every time. The way this works is it uses a time stamp or the timer to determine the seed. So if there's a long time between 2 calls to random, the seed will be very different, and therefore it will appear to be pseudo-random. However, given the speed of this computer and C#, this is not going to work, and so we have to generate a random object outside of this loop. So we can either move this out into here, and then what we can do is see what the issue is here. And of course, because this is a static method, I have to declare this as static 2. And now you'll see that code is just fine. So if I run this now, you'll now see that we are in fact getting a random sequence of digits, 1C2. Let's try running that again. So if you're using C#, beware of that gotcha. How else could we do this if we don't want to make this a static global variable within the class? What we can do is we can move that into our get hex color function, and we can declare it outside of the loop here. And then what we can do is we can take in a random and call that random object and pass that random object to this function. So if we try running that now, we'll see that we get this same, or it's now that it's working. So it all depends upon whether you want to have a a permanent global variable, or whether you want to generate that inside of here and then send that to your random object. Send that to your function as the random object. So just remember, there is a little bit of a getcha or a gotcha even, when dealing with random numbers inside of a loop in C#. So I'm hoping that that's assisted you in how this works, how to convert that to C#, how to deal with data types, how to look at issues with random numbers, and how to ensure that we can convert this code. And you can see that there is not a huge amount of difference between exam reference language and C# or VB or Python. The key is video 1, understanding the logic, understanding the algorithm. And that's why we focus a great deal in computer science on algorithmic thinking, because if you don't understand the logic, if you don't understand the algorithm, then you're certainly not going to be able to write the code to do that. Once you've got the pseudocode, or you understand the steps, the actual code itself, whatever language it is always very similar. If all you came here for was to look at how to convert the pseudocode to C#, then feel free to go. For those of you that didn't quite understand the issues regarding random and pseudo-random and seeds, I thought I would just add this to the end of the video. So what we're going to do is I'm just going to take a little bit of this code here, and I'm just going to, for the moment, I'm going to just put that into here, and going back to what we had before, I'm just going to generate this random number, and I'm going to just console.write line that random number. And what you will see is at the moment I'm not putting any seed in here, and so let's just also, don't forget to, when this is finished, console.readline, just so we can keep the console open. And let's see what happens when we run this. And we get 2, 9, 10, 13, 1, and 6. And if you remember that we've taken this random object outside of the loop. But if I put this inside of the loop, then let's see what happens again. We get the same number every time. And then we get the same number every time. So let's just take this back outside the loop, but this time I'm going to give it a seed value of 1000, and I'm going to run this code. And you'll see we get 2, 3, 11, 0, 10, 6. 2, 3, 11, 0, 10, 6. So I'm going to run this code again, and you'll see we get 2, 3, 11, 0, 10, 6. I'm going to run this again, and guess what we're going to get? 2, 3, 11, 0, 10, 6. So the point is that this is not a random number generator. What this does is it generates a sequence of numbers based upon this seed value. So if I change the seed value just to be 1001, you'll see that we get 10, 7, 6, 3, 2, 4. And guess what? If we run this again, we're going to get 10, 7, 6, 3, 2, 4. So if you're making a game, for example, and every time you want the exact same sequence of events every time, then you would seed it with a static number like 1000 or number. If you make that a timestamp, well, every second the time is changing, and therefore the seed will change every time you run this program. And so the point is that it is not a random number generator, it is a pseudo random number generator that for a given seed will always give you the same set of numbers. And the way that we make it pseudo-random is by providing some form of random seed, which in this case is potentially the time, which is changing. And that's how we can make it appear, as in this case, if we now use the without any parameters, we get 10, 4, 3, 12, and we get a different set of numbers. And that's because what that's doing internally is saying, let's set this to be the time, and that changes every time we run this code. So that's why you have to be very careful with random numbers, because we don't have such a thing as a truly random number generator. And of course you can use that seed to your own advantage, in that if you want a character every single time to follow a specific set of actions, if you seed it, then you can guarantee that those exact same actions will occur every single time that you run the program, or every time your user uses the program. So I hope that's been a little bit of information on the gotchas regarding random and seeding, and why we need to do what we did to make that work.